Tom Dale stepped in, and he good enough to fill the space. Tom is not a Rubyist. We actually lied to him and told him this was a JavaScript conference. So be sure to ask him lots of hard questions about Ruby. Tom is an engineer at Tilda, and he is a self-confessed hipster because he was doing JavaScript before it was cool. So this is not Tom Stewart doing impossible programs. This is Tom Dell talking, telling you to stop breaking the web. Thank you, Tom.
Thank you, Josh. Well, I'm glad I could be the first to welcome you to GoGaRuCo. You probably recognize me most likely as the angry telephone booth on Twitter. I'm going to give you a version of a talk. I just came back from Berlin last week. I was in Berlin for JSConf EU. When I went on stage at JSConf EU, I looked a little bit like this, full hipster, but also, most importantly, a big beard, a big overflowing beard. And the reason for this is that my beard trimmer was not charged, and I forgot that in Germany they have 240 volts instead of 120. So I went and I tweeted this out right as I got to the conference. I said my beard trimmer only supports 120 volt outlets, so I'll be doing the talk in character as a wild-eyed lumberjack. However, I learned an important lesson from this, which is don't ask for sympathy on Twitter, because literally the only response I got was this. So today, well, first I should say, yesterday, Yehuda was on stage and he was talking to you a little bit about double MVC. Well, today I'm here to say, fuck that. I'm going to talk to you about hen-to-couple MVC. That's right, over 11 MVCs. This is a totally new paradigm. This is going to blow double MVC out of the water. This is how we all want to be architecting our applications. In fact, to kind of go along with Yehuda's talk, I actually drew up a diagram of what this architecture looks like. But actually, that's not what I want to talk to you about. Actually, before I talk about computers at all, I want to talk to you about phones, about telephones. And specifically, I want you to think about the phone that you have in your pocket probably right now. Probably it's like an iPhone or an Android phone or something like that, and more than likely it has more computing power than what we as a human race used to put man on the moon. And I think that's pretty incredible to think about. And the thing that's also incredible to think about is that I can pick up from the United States, I can fly to Germany, and I can land, I can get off the plane, and assuming I'm willing to pay AT&T's usurious rates, I can actually still receive all of my phone calls, all of my texts. So there's this global telecom infrastructure that we have. And if I'm out at a bar in Germany, this image is what you get when you Google having fun in a bar. If I'm out having fun in a bar, and I meet someone, even as totally foreign country to me, and I want to keep in contact with them, especially if it's a cute girl, what do? I say, can I have your phone number? And the reason that I ask someone for their phone number, in fact, is because of measles. Let me explain. And by the way, do not do a Google image search for measles. It's freaking disgusting. So let me explain what measles has to do with phone numbers. So I'll just give you a brief history of the phone number. This is a gentleman by the name of Alexander Graham Bell. You may have heard of him. He was the first person in the world to ever make a phone call. Now, he actually did not need phone numbers because he owned the only two phones in the world, and they were connected directly together. But as you can imagine, this solution would not scale for very long. So they had to invent something called the exchange, the telephone exchange. And this was a bunch of people sitting in a room, and when you wanted to make a call to someone, you would pick up the phone, and you would be connected to the exchange, and you would talk to the person on the other line, and they would ask you who you wanted to talk to. Now, initially, they would ask you by name, and you would give them the name, and they would have to figure out which of these plugs on the wall corresponded to the person with that name that you wanted to talk to. So that meant that they needed to be very trained and they needed to be very experienced to do this quickly. Otherwise, it got very slow because they didn't have computers, and this is essentially an ON operation. So during a measles epidemic, there was a physician by the name of Dr. Moses Greeley Parker. And he worried that, you can see how closely these people are sitting and working together. Measles, of course, is very contagious. He was worried that if there was a measles outbreak in the exchange, it would bring the communication infrastructure to a standstill. So he thought, you know what, it'll be a lot easier to train replacement operators if instead of asking for someone by their name, you just asked for them by the number, the index of the patch of the circuit that you're patching them into. Just to reiterate here, the reason that you dial a phone number on the supercomputer in your pocket is because of measles in the 1870s. So despite phone numbers increasing the efficiency of the human operators, the process was still slow and expensive. So I found this out while I was researching this talk. Even into like the 1920s and 1930s, if you wanted to make a long-distance call, the average time that you spent just like waiting and talking to the operators before you even got the person on the other end of the line, 15 minutes. You really needed to want to talk to the person on the other end of the line. So to alleviate this, in the early 1900s, they started slowly rolling out these automatic exchanges. But by that point, of course, telephones were widespread. People knew how to use them. People were used to phone numbers at this point. And of course, you couldn't replace all the operators overnight. So you had to gradually phase out this old manual system and replace it with a new automated system. So I just want you to think about the fact that the phone in your pocket today bears basically no resemblance to a human being sitting in a phone exchange in the 1870s. The thing that you use has almost no resemblance to a telephone set that you would have used even back in the 1950s. You can take photos, it can travel with you wherever you go. The infrastructure is totally different. The infrastructure that underpins this entire system is completely different than a human sitting in a room manually patching two circuits together. And yet, here we are in 2013, and the way that I call you is to punch in a series of numbers on my telephone. This unique numeric identifier was invented when, as a business owner, you seriously had to consider, will there be a measles outbreak, which hopefully none of you have to think about in your businesses. This is still the most popular option for me to get a hold of someone. So in theory, we could have replaced the phone number at any time, but I think there's a lesson to be learned here, which is that new technology, unless it's orders of magnitude better, really needs to interoperate with the last generation of technology. Rarely can you replace it wholesale. So even 100 years later, the phone number has evolved, but it hasn't been replaced. So I think you might say that the phone number is the universal UI of the phone. And wherever I go in the world, I can, no matter what handset, no matter what country, I know how to reach someone on the other end. And I think we actually have a similar thing for the web, the universal UI. And of course, I'm talking about the URL. So what we consider to be the original web browser, this is a screenshot of Tim Berners-Lee's original web browser running on an X machine written in 1990. So in 1990, this is the first browser, but it was hardly the beginning of this idea. Hypertext documents, this term hypertext was coined by Ted Nelson in 1963. Are there any AngularJS developers in the audience? Can you raise your hand? Any Angular developers? So for the Angular guys, Ted Nelson also coined the term transclusion. So can't win them all, I guess. That's an Angular joke if you've never used Angular. So even 50 years ago, that's not even the origin of this idea, because all the way back in 1945, Vannevar Bush published a paper about the memex, which is really the prototypical idea of these documents linked together by how they're related. So we should take a moment to reflect on the fact that all of these things are just systems. The World Wide Web, the idea of hypertext, Bush's memex, these are all systems for storing and navigating documents. And yet, here we are discussing things like JavaScript, a Turing-complete language that's in these document viewers. So how did it end up that this document viewer got a Turing-complete language inside of it? Well, I think if we go back, it's really because of some clever hacks that we thought of. Two clever hacks in particular. So the first hack is the cookie. Sadly, not the delicious kind, the privacy-invading kind. So HTTP, by design, was a document delivery protocol. It was a stateless protocol. Basically, I want to go see a document, you want to go see a document. Every time we go see a document, we get the same thing. Great. But then someone figured out, hey, sometimes it's useful to be able to tell the difference between who's visiting and giving them different content based on that. So essentially what cookies did was they layered state on top of HTTP. And I think this layering state on top of HTTP was really the key thing that we needed to start building applications as opposed to documents. The second hack was realizing that the browser could be more than just a document viewer. You could almost treat the browser as a viewport onto this server application running thousands of miles away in a data center. So this is basically treating the browser as what we'd call a thin client. So the data lived on the server, the application logic lived on the server, even deciding what the user saw, deciding what HTML they saw, all of those decisions lived on the server. As far as the browser was concerned at this point, remember there's no JavaScript, you were still just looking at a document. This document just happened to be dynamically generated. So every time the user interacted with the page, by clicking a button or clicking a link, the browser would have to transmit some command to the server. The server would have to figure out what that meant for the application, and it would send back a whole new representation of the user interface. So if someone else makes a change, before you go and talk to the server, you will be none the wiser. So the way that I think about writing applications like this is kind of like being at a club with the strobe light going. Like there's no continuous movement. It's kind of choppy, right? You get like bursts of information. Or if you're familiar with the zoetrope, the early precursor to the movie, it's like that zoetrope starts spinning too slowly. It doesn't really look like movement. It just seems like a series of still images. And the thing I just want to drive home, and I think Yehuda alluded to this a little bit in his talk yesterday, I don't want to deride this, but it's important to understand that this model is a hack. Large parts of the global infrastructure, the global economy, are built on this hack, granted. And I want to be clear, I'm not using the term hack in the pejorative sense. I'm using it more like during Apollo 13, when the NASA engineers were able to like MacGyver the square CO2 scrubbers into the round sockets. It's this mixture of like awe and delight combined with this feeling that probably we shouldn't attempt this again in the future if we have the option. But there is an unintended side effect that fell out of cajoling this document viewer into an application viewer. And that, in my opinion, is what ended up being the strength of the web, the thing that let the web win out over native applications on the desktop, at least. And I'm referring, of course, to the URL. So in order for the browser to act as a viewport on this application running on the server, you needed to tell the server which view, which part of the application the user wanted to look at right now. Thus, in order for someone to build a server-rendered web application, the URL is quite literally the first thing you have to think about. No URL, no web app. So this has pretty important consequences. Essentially, the hack of turning the browser into this thin client meant that collaboration, though crude, was baked into the platform by default. So you could share very easily, you could collaborate very easily. And more than just sharing, you also got things like bookmarking, so you can navigate your way through Byzantine UIs sometimes and always come back to them. Apps are also forkable. People don't talk about this enough. On the web, if I'm in the middle of a task and I see something that I want to follow up with later, I just command-click on my Mac and it will open it up in a new tab, and I can pick up right where I left off. This is a killer feature that we all use every day, and it's something I've never seen a native application implement. So this is all well and good. Server-side rendered web applications, they've got us very far, and they have shown us the importance of the URL. But server-rendered applications have a problem as well. The two most important, in my opinion, one, they require a round trip to the server every time the UI needs to be updated. So if you're offline or you have a slow connection, that sucks. Second, they require the server to rebuild client state every time a request comes in, which is both complex and, as we learned from DHH's Rails keynote, very difficult to cache. So what we needed was some kind of programming language that would run closer to the user. And for better or worse, we got JavaScript. But especially at a time when the average internet connection was very high latency, JavaScript gave users immediate feedback on what they were doing. Instead of taking seconds to go back to the server, you now got responses in milliseconds. But JavaScript was very slow, and JavaScript was very limited. So you definitely couldn't write entire applications in it. So what happened is we started slapping JavaScript on top of our web applications, which is a little bit like putting a rocket launcher on a minivan, but it's the best we had at the time. But as we started learning how to do this stuff, we started pushing more and more up against what JavaScript and what the browsers could do. Think about the first time you ever used Google Maps. It was pretty mind-blowing, wasn't it? You were like, holy crap, I didn't know the browser could do that. So we started asking for more, because we wanted to do even cooler stuff. So in fits and starts, the browser vendors began to give us what we were asking for. And we've started to write more and more of our web applications in JavaScript, which I think is fantastic. But now, Google image search crossroads, we are at a crossroads. The majority of web developers really, truly want to cling on to this ancient hack of a model of running all the stuff on the server and having the UI be a viewport. It feels very comfortable. The tools are very mature. It's just familiar. And a lot of people are trying to take this kind of like 1 foot timid step out into the future of writing JavaScript applications. But now, now you have 2 problems. Now you have tried to keep some part of the state in the client, some part of the state on the server, and now you have a distributed computing problem. So sorry. But then there are those who realize, hey, we have our JavaScript future. The JavaScript future is here. And they started to write 100% JavaScript applications. But you've probably used some of those applications, and they suck. They feel broken. People using them, they're like, this feels broken, and it feels no different than the Flash dystopia that we almost found ourselves in the early 2000s. So I want to argue that in the same way that the phone number is the universal UI of the phone system, so too is the URL the universal UI of the web. So think about this. With a JavaScript application, you are not required to think about URLs at first or at all. Apps will run just fine without them, but they'll feel broken to users. So if we want to step into the JavaScript future without breaking interoperability with the past, we have to somehow marry these two in a way that's cohesive and in a way that doesn't introduce undue complexity. So I want to ask you to think about what exactly is a web app. But the way that I like to frame that question is by asking you, what is a native app? And I would argue that in order to build a native application, there are a few things that we think that we need. So the first one is sockets. We need to be able to open a socket. We need to be able to manually allocate memory, 3D accelerated drawing, 3D graphics, access to local file system, concurrency. We saw a great talk on threads and concurrency. This is a little bit of a JavaScript troll. I don't know if you guys know this. JavaScript doesn't have integers. All numbers are represented using IEEE 754 floats. But I have really bad news for you as web developers. Really bad news. The bad news is that literally all of those things are in browsers today. You can use literally every single one of those things in evergreen browsers like Chrome, Firefox, and Internet Explorer. So we no longer have an excuse for why we shouldn't be architecting our applications like native applications. So I ask a lot of people, what makes you a web developer? And a lot of times what they'll tell me is, it's because I write HTML, CSS, and JavaScript. But I would argue that this is not what makes you a web developer. You are a web developer if you build web applications that have URLs. Because if you're building applications without URLs, it doesn't matter what you use to build it. If there's no URLs, you literally may as well make an exe and upload it to your FTP site. So the question is, how do we build applications that respond and behave like native apps, but don't break the web? So historically, this has been MVC. I think that we have introduced a kind of a new paradigm. This is not like an official term or anything, but the way that I think about it is RMVC. You need a router. You need some kind of object that does, as Yehuda was calling it yesterday, bootstrapping. To bootstrap all of these objects together. It needs to be a single source of truth. It does things like configure models, views, and controllers based on the current URL. And when any of those things on screen change, it goes into the URL and it updates it. So you can think of you can almost think of the URL as being the serialized form of your application. And the more I thought about it, the more I thought about the URLs that we see in our applications. The URLs actually map really, really well onto the MVC architecture. You just need an object in your system that will do that mapping for you. So for example, sometimes you have this implicit model. This is /photos, right? It says, give me all of the photos that the application knows about. Or sometimes you have a specific model, photos /3. So part of this is the view or the template. The other part is identifying the model. Sometimes you want to have controller state, like how is this thing sorted? This actually maps pretty cleanly onto the query string. So for the last couple of years with Yehuda and the other members of the Ember community, I've been working on a JavaScript framework for building these applications using this native style architecture, but in a way that's respectful of the URL, that's respectful of our history. So what I'd like to do with you guys in the last 10 minutes here is to just build a blog app in exactly 50 lines of code. Now, I don't have enough time to go through building the whole thing, so what I'm going to do is share with you guys, here's a bit.ly link to JSBin, if you guys want to type that in and bring it up on your computers. This is hitting my DreamHost hosted blog, so hopefully you guys don't bring that down. I don't think I've ever had this much traffic at once before. But this is just an Ember application that will pull in a JSON feed of blog posts and render them. And I think it's pretty impressive that it's only 50 lines of code. So I'll give you just a couple more seconds to open this URL. And then once you've got it up, I'll give you a demo gods willing. Okay. So hopefully if you were able to get that URL down, you should see something like this on your screen. And if you come up to the right-hand corner, you should see this link called Edit in JSBin. If you click on that, that will actually give you the source code. What's going on? 503? Of course. I'm getting raw about raw GitHub. Sounds good. Okay. Well.
Reference error, can't find variable, Ember line 1.
Yeah, raw GitHub where all the JavaScript assets is being served. You guys just brought it down. Congratulations. Okay, we got a couple. Okay, so anyway, this source code is available on GitHub as well. So if you guys want to bring it up, let me mirror. It's also on github.com/tilde.io/blogger-client. Can you guys see this? Got that down? Thank you, GitHub, for not going down through my presentation. Okay. All right, so I just want to go over, so this would be a much better demo if I was able to give you an example of exactly what it's doing. Let me just clone this. Okay, awesome. Seems good. Whew. All right, so if you clone the repository off GitHub, if you open the index.html file, it will give you this application. So this is just a very simple blog reader, but it does a couple of cool things. So the first thing is it has a posts link along the top. You can switch to the About page. It'll switch you over to the About. Click back on Posts. You can see we have a list of awesome blog posts here on the left-hand side. So if I click on one of these, like the Rails Omakase post, you can see that it shows it down here. And I can switch between these two things. Now, the thing that I want to call out is that as I'm navigating around the application, these are building really good URLs. So, for example, I can command-click on one of these posts, and you can see it'll open it up on the other tab, but the behavior is correct. I can hit the back button. I can go forward. I can refresh the page. These are things that I would actually expect to break in a JavaScript application, sadly. But these things all work as we would expect. It's even got a really cool editing UI, which I think is really neat. I think this starts to show some of the power of what you can do when you just embrace JavaScript instead of trying to do rendering on the server. So for example, this is all Markdown. So I can say like, hello, GoGaRuCo. And you can see, so you can see that I've got this live updating Markdown editor. So let me show you how we did all of this in just 50 lines of code. OK, so if you open up that Git repo in your editor, there's a single file. It's all in the app.js file. And the first thing that I want to draw your attention to is the router. So the router, if you're familiar with Rails, is very similar. We take a URLs first approach. So in the router, this is where you define all of the URLs that exist in your web application. Now, once you've defined these routes, each route is mapped to a template. Now, the first template that you want to think about is the application template. So if you're familiar with Rails, the application template is just like the application layout. It's a template that always gets rendered no matter what page the user is on right now. So in our example, you can see we've got link to post. This is a handlebars helper for anyone that hasn't used handlebars before. The cool thing about link to is A, it generates real, honest-to-goodness URLs based on the current model data. And 2, it automatically adds an active class, so you can style your links to give the user a hint about which URL they're on right now. And then lastly, this thing down at the bottom, you can see it says outlet. That's like yield in your Rails template. So this is basically saying this is the application template. This is the template that's always on screen. Outlet is where any sub-templates are going to get rendered into. So next is the post template. I've omitted some of the more egregious HTML that I had to write to make Twitter Bootstrap look good. But the key thing here is that in Ember, every template is backed by a model. And so all this is saying, if you've never used handlebars before, is for each item in that backing model, which in our case is an array, loop over it and render a TR element. And again, you can see us using the link to helper. And these curlies are just pulling properties off the model and putting them into the HTML. Now you might be wondering, okay, oh, and one other thing I should call out, this is the post template. If you have a posts route, then you have a posts template that goes along with it. Now the question is, where does the model for the post template come from? And again, to get back to this new architecture that we're introducing, this new RMVC, we have this object in the system called a route. And in Ember, as in Rails, all of these objects are stitched together based on their names. We just rely on a naming convention to remove the need to write all this imperative code. So in this case, we have a very simple object. It's called the posts route because it's defining the model for the post template, the posts route. And we have a hook called model. And model is just a method. It's just a hook that returns some object that should be passed to the template to be rendered. And I think one thing that's really neat about our model support is that you can do it synchronously, of course. If you look at the example we gave you, it's just returning some synchronous fixture data. But I can return anything that returns a JavaScript promise, which is just like a promise for a future value. jQuery, how many of you have used jQuery in your apps? Any? Most jQuery? OK, basically everyone. Awesome. So jQuery for a number of years now has had a promise API. And the promise API basically allows you to write code that looks synchronous, but in fact behaves totally asynchronously. This will wait until the JSON request comes back from the server before it renders your template. So a couple weeks ago, I wrote a blog post about progressive enhancement. Maybe some of you read it. And in it, I said, don't be ashamed to build 100% JavaScript applications. And the thing that I want you to take away from this talk is that the browser is not HTML, it's not CSS, it's not even JavaScript. The browser is a box of content with a URL field at the top. In the same way that despite our global telecom infrastructure being totally different than what it was in the 1870s, we still punch phone numbers into our smartphones over 100 years later, and my suspicion is that we will be saying the same thing about the URL in another 100 years. So don't be ashamed to build 100% JavaScript applications, but if you do, make sure that you do so with an understanding and a respect for what gives the web its strength. Thank you.